the last one for this lecture, and then we can move on. Is the following. We're going to have three pieces of objects. So we're going to have 200 grams of iron. So here is iron. 0.2 kilograms. That's 200 grams. And the temperature is 120 degrees Celsius. You have a piece of copper, 0.15 kilograms. 0.15 kilograms, and the temperature is minus 50. And we have a bucket of ethanol. And the ethanol, we have 300 grams of it, which is 0.3 kilograms, and its initial, or its temperature is 20 degrees Celsius. Okay? So you have iron at 120, copper at minus 50, ethanol at 20, and what you're going to do is this. You're going to throw the iron, the copper and the iron, put both of them into the ethanol. So you will have your iron, and you have your copper, and you have your ethanol. And the question is, what's the final temperature? They will reach some final temperature, right? It would be common. All of them, they will have that same final temperature. They will reach some equilibrium. The question is, what's the equilibrium temperature? The question here, our system is the iron, the copper, and the ethanol, right? These are the three things. Are we going to add heat from the outside?
No.
From outside these three? No. So it's, the iron will lose heat, right? Because it has the higher temperature. The copper is going to gain heat, and the ethanol likely going to gain also because the iron is so high. Okay. And the question is, what's the final temperature? Yeah. Okay. So we're not going to add any heat from outside. So the iron is going to lose, the other two are going to gain, but in total, is there a net gain or net loss for the total? No. So the total is just going to be zero. The total heat is just going to be zero. And so we're going to have this. The heat lost by the iron, Q iron, plus Q copper, plus Q ethanol is going to be zero. Loss is going to be, this one is going to be negative, this one is going to be definitely positive, and this one is going to be likely positive. But the math will tell us. Okay? We just have this equation here. Again, why is it equal to zero? They will reach equilibrium. And did we add any heat from outside these three? No. So that's it. So from outside we added nothing. So that's equal to zero. And this is the heat exchange between one lost, one gained. That's it. For the iron, it's going to be the mass of the iron. I'm going to write it right away. It's changed. The temperature is changing. And the mass of the iron is 0.2. The specific heat of iron, MC delta T, right? What's the specific heat of iron?
449.
That's right, 449. Times the change in temperature, what should I put? T final minus T initial. What's the initial? And then plus for copper, 0.15, right? The mass for copper. Specific heat for copper is 385 times delta T. It's going to be T final minus what? Yeah, it's negative 50. Don't forget the minus, because it's going to be minus minus, it's going to be plus. So it's negative. That's good. plus for the ethanol, mass of ethanol is 0.3. Specific heat for ethanol is 2400, yeah. And then T final minus the initial temperature for ethanol, which is 20. That's a good question. What we're going to do, we'll have more complicated problems like that. We're going to assume it's not going to vaporize. And if we get a temperature where it doesn't vaporize, let's imagine it's water. Water vaporizes at 100, right? Boils at 100. So imagine it's water and we get the temperature to be 90. We know we're okay, right? So the boiling temperature for ethanol is 78 degrees Celsius. So if this temperature turns out to be less than 78, we're fine. If this temperature turns out to be more than 78, I will show you what to do. We have, I think I have more challenging problems in the worksheets than in the homework. So what you do is usually just assume the nicest thing, and if it's the nicest thing, that's great. And if it's not, then you have to do more. So that's a linear equation, one unknown, you solve for T final. I am not going to spend time on doing that, so we're just going to write T final, just have to solve it. It turns out T final is 25.7, approximately 26 degrees Celsius. 26 degrees Celsius is definitely not the boiling temperature for ethanol. Oh, yeah, right on time.